So he's one of the most acclaimed scientists who has spent the most time stationed in the Maldives. And his research is mainly on land, ocean, and atmosphere. He has been studying transboundary air pollution throughout his career as well. His academic career began with his PhD from the Indian Institute of Meteorology and also from the University of Pune. He has published over 50 papers in some of the established journals, including the National Academy of Science, the Proceedings of National Academy of Science, and Science Advances. He's also been recognized with various prestigious prizes, including the Paul Crutzen International Climate Fellowship and the Marie Curie Fellowship. He's currently working in affiliation with Indian institutes and also the Stockholm University of Sweden, but he affiliates with many other institutes. He's also a collaborator and a mentor, and he's currently supervising various students doing PhDs and masters from various universities throughout the world. His experience also includes his work in the Arctic and the Antarctic, as well as some of the most populated parts of the world, including India, Bangladesh as well. So it gives me great pleasure to introduce Professor Krishnakant Budhavant. Ladies and gentlemen, Krishnakant Budhavant.
Thank you so much, Dr. Ibrahim, for a nice introduction, and good afternoon, all of you. So before start my presentations, I'd like to thanks to all entire MNU team to conduct this conference, which is beneficial for many ways. And now, as I said, Dr. Ibrahim suggests I will talk about more on carbonaceous aerosols. So I have made my presentations into 5 parts. First, I will talk about when the winds come from northeast monsoon. Second, I will talk when the winds come from southwest monsoon. And is there any changes when there is a dry aerosols or it's kind of wet aerosols? The 4th parts, I will talk about how much pollution is emitted by the Maldives, especially Malé City, how much is local contribution, how much is long-range transport. And at the end part, I will talk about COVID-19. Actually, that's a slowdown, gives good opportunity to study the climate changes if you slow down the overall community activities. So if you see this first slide itself, this gives the idea of my presentations. If you see the center side, a center picture that gives the black carbon radiative forcing over this entire world, and there are several hotspots we can see here. And I'm going to talk about 2 hotspots today, like South Asia and Africa, where they have huge kind of, they produce huge kind of black carbon emissions in the atmosphere. So doing this research, actually, any kind of research, we need research facilities. So research facility includes, obviously, instrumentations, as well as you need to have perfect locations to fill that your objectives of the studies you are going to conduct. And here you can see the picture of a climate observatory, which is placed in Hanimadu. You can see here one tower, that is height is around 15 meters. So we conduct most of this air quality observations for that tower. So that will give to help to reduce a local impact around the station. So we'll get whatever these observations we are doing, that is from 15 meter height. Actually, this observatory is established in 2004, which is initially funded by the US and Professor Ramanathan and well-known scientist Paul Cousin, who got Nobel Prize. So these are the founders of this observatory. They find, like, before that there is a kind of some history behind to build this observatory. So like in 1999, there are like huge experiment conducted over these Indian oceans. They found there are like a layer of pollution forming over the South Asia. So they gave a name as atmospheric brown clouds. So they want to study that thing. So they came with the locations. Like the Maldives, they find the perfect locations. Initially, they started observations at Kaddu, but later on they shipped, because of there was some logistic problems, so they shipped it to the Hanimadu. And since that, we have like time series observations. Currently, Professor Gustafsson, Orion Gustafsson, is taking lead from Stockholm University, and there are several groups which is involved in the research. And especially this is not happening without help of Maldives government. So we'll especially thanks to the Maldives government to provide this kind of facilities. So we can say this is only super observatory in the entire Indian Ocean, say on South Asia, that gives such kind of facility time series data. So we can see that not only short-term changes in the atmosphere, but also long-term changes in the climate change. And these are the facilities. First, you can see the platform of the tower, which have several instruments located, which used to measure the air quality, radiations, gases. So we do all kind of research there. Here are some instruments that belongs to the NASA network. Also, some instruments are like GAW network. So we have like varieties of observations and instruments. We have several research directions there. And these are the current institutes. They are actively participate right now. There are several institutes, organizations, but these are the currently active organizations: Stockholm University, ISC Bangalore, NASA, Scripps Institute of Oceanography, FMI from Finland, Canadian groups. So there are several groups. Those are deployed their instruments there and doing the observations. And these are the research articles which are recently published from this, whatever the research we do in the Maldives Climate Observatory. In this, I'll especially talk today about only carbon aerosols. So we are not only generating data and publishing papers. We also give this data to the policymakers or government to make their decisions and implement their policies. And this is like, you see some examples like IPCC report, CCA reports. So these are this aspect, like how much that observatory is important, not only Maldives, but all our world scientists. The carbonaceous, if you see the carbonaceous, there are like a big group, but today mainly I will focus, those are mostly related to the climate change and make more impact to the climate. First one is black carbon. Black carbon is, because it absorbs more sunlight, so it's causing global warming. And there is a kind of, mainly carbon aerosols divided into black carbon as well as organic carbon. So there is a one group in that organic carbon which is responsible for absorbing sunlight. That is we call as a brown carbon. Actually, now onwards I will give the terms BC and like a brown carbon, just like brown carbon means light absorbing carbon. It will absorb the sunlight, so that's why this is important there. The first thing is like, what is the black carbon? Everyone knows the particles which is like black carbon there, which emits due to incomplete combustions or fuels, generate energy. And it can be travel like for 4 days to the weeks of times. Sometimes travel more than 3 weeks, 4 weeks. And it is important because if you see that CO2, it absorbs millions times more energy than CO2. That's why that's very important, and it's also causing global warming. So we call as a short life climate pollutant here. So obviously there are different sources you can see in the picture itself. Forest fires, open burning, some transportations and industrial activities, these are the sources for black carbon. So it is, then question comes, why it is important if there is a kind of source differences? Because there are, for government it is very beneficial, because if you have black carbon comes from fossil fuel or biomass burning, so they can make strategy that way. But scientifically it is also very important, because they have different characteristics. If you see that the carbon which is come from fossil fuel and the carbon which is come from biomass burning, it has different properties. Especially that properties are, when we talk about fossil fuel, it gives stronger warming than biomass burning. It also affect the stronger surface albedo reductions. It also cause a decrease in the optical depth. And obviously, if you see these models or emission inventories, data mostly depends on this, how much sector that emits the energy, and based on that calculations, they estimate all these things. But if you see the emission inventories, over South Asia, we have around 10 emission inventories. They produce a lot of data, but the data and the real observation, there is a lot of uncertainties there. So the uncertainties varies 100 to 500 times, which is reported by Bond et al. In 2004, as well as recent publications. So this data is in use for climate models. So if you use this data, again, there is a kind of differences, the real observations and model results. So if you see that factor, it's 2 to 3 times, 2 to 3 times, they underestimate the BC effect. As I told, this is kind of two sources for black carbon. That also, EC means elementary carbon, we can call as a black carbon also. So it comes from fossil fuel, biomass burning, and then other part of this carbon is organic carbon. It comes from all three sources. So we need a technique or method so we can separate out it is from biomass burning or fossil fuel. So we have robustic methods we use carbon-14 to separate it out. It is coming from fossil fuel or biomass burning. So if you have carbon-14, we can separate out. And if you have stable carbon isotopes carbon-12, carbon-13, with the two models, we can separate out whether this biomass burning is coming from C3 plants or C4 plants. So that also we can separate it out. Now I'll start with the first part. I will talk about northeast monsoon. When the winds come from South Asia, which happen generally in northeast monsoon, you can see here a broader picture. This is kind of satellite measurements, and this is observations from the local weather stations. So we can see predominantly winds come from northeast. And here are this model results. Actually, this is back trajectory based on batch trajectory. This is 5 years pictures, 5 years from where the wind is coming over the Maldives from last 21 days. This is a model run for 21 days, and during that period, how much wind comes over the Maldives. So there is a kind of broad region where the wind is receiving to the Maldives. And here you can see the red parts where there is a more frequent air masses are coming. So we can say during this winter time, mostly the winds come from IGP. IGP is an Indo-Gangetic plate. This is a fertile region. It starts from Pakistan, northern part of India, to the Bangladesh. So this is kind of, we call it as IGP. And here, this figure, you can see this AOD map. Actually, AOD maps means aerosol optical depth. That gives idea of aerosols, how much aerosols present in the atmosphere. If there is more AOD, more type of aerosols. So here you can see here, there are red spots. That means here, red color, that means it has more kind of air pollutions there. So, and during this winter time, this wind is travel from these directions. Initially it start from, because of, this is happened because of Himalaya. So wind start from this Pakistan through Nepal, India, it's through Bangladesh, and it is coming to the Maldives. And also sometimes winds come to the western part of the India. So that is really good locations. We can track all the pollution sources which come from different sectors to the or the northern Indian Ocean. And here you can see the first satellite pictures. Here you can see the haze. Haze is nothing but it's kind of recorded from satellite, NASA satellites. You can see the fumes. It's a clear indication there is a kind of pollution over South Asia during winter time. And the wind is travel this way. And here is the Animodu locations in the Maldives. So this is the best place we can track all these air fumes. Now I'll first talk about full compositions of aerosol compositions, and then slowly I will move to the carbonaceous aerosols. So first figure you can see here, number concentrations. If you see within 1 centimeter cube, how much particles are present. It's, if you see in the graph, it starts from November to April. So the graph get increased. This is the even the concentrations of the get up to 4,000 number of during this pollution episodes. And these are marked with this different color. This means wind is coming from Arabian Sea, Bay of Bengal, and it's come from IGP. So you can see here clear during this IGP means event, the mostly winds come from that sector. That brings a lot of pollutions to all the Maldives. So these are the number concentration we can see clearly here. And also, now if you go the more details, like some particles we can't see by the eyes, but we have some sophisticated instruments, we can measure the particles which are not visible with our eyes. So we have instruments like a DMPS, which has like capacity to measure the particle size from 7 nanometer to 0.5 micrometer. So we can see this most. These particles mostly comes in the fine mode. So this is transported particles. Obviously, this is kind of coarse particle settle. So we observe the mostly all particles present in the fine mode. And if you see the separate wise, this based on these data sets, we separate out these particles. If you see here, the particles which come from Arabian Sea, that has a unimodal. But other two fumes, like separated, it has bimodal. So it is kind of a mixture of different sources. And also you can see these particle numbers. There are large difference between this Arabian Sea and the IGP. And just now I talked about aerosols optical depth. If you see here, aerosol optical depth means during this period, mostly all the AOD values are more than 0.3. If you see that generally atmospheric scientists, they believe like observation, AOD, if it is more than 0.3, it is kind of more polluted one. And the next concept is if you see this one, AAOD. AAOD means aerosol absorption aerosol optical depth. So that gives the particle which are not only present in the atmosphere, that is only absorbing more solar energy. So that is called AAOD. So we found that AOD levels are like, if it is again, there is criteria, if it is 0.03 above, that is called more pollution episodes during that period. And if you see the particular concentrations of black carbon and organic carbon here, we found like, if you do the correlation analysis, we found like non-sea salt potassium. It's a potassium we can consider as a very good tracer for biomass burning. If the biomass burning happening, we can get more potassium. So we found a very good correlations with this, all these three. So we can conclude this like it came from same source, also it's come from biomass burning. And here we can see the, if you divide aerosols like a fine mode and coarse mode, like in general, people talk about more air quality, they talked about PM 2.5 and PM 10. So PM 10 means very small particles, which has aerodynamic particle size like below 2.5. And coarse particle, which is like range from 2.5 to 10 micron. So if you see that coarse particles mostly comes from the sources from soil as well as the sources from sea salt. We can mostly they stay in the coarse particle. And the pollutions like anthropogenic pollutions polluted, like it comes from black carbon, organic, they present in the fine mode. So if you see the overall compositions, mostly during this winter episodes, mostly all particles we found in the fine mode. And if you see the total composition of the aerosols, PM 2.5 and PM PM10, we can see there is a kind of more sulfate, then organic carbon, and then remaining things. So the takeaway message from this study, actually, it's kind of whatever the air is coming to the Northern Indian Ocean, it's well mixed. And mostly the aerosols are in fine mode, and the particles, due to with this AOD, we can conclude that is kind of IJP is a more polluted area over South Asia. Yeah, now I will talk about this physical and chemical physical and optical properties of black carbon. If you see that something is like some fuel is burned, so it emits black particles. So if the black particles emits the place during that, there is local, you can say local effect, that is not much changes. But when the black particles travels from emits in the atmosphere, and with the air current, it travels long distance, like for example, 7 days. So their properties get changed. Like the particles which emits, they travel, that means get more deposited with the different kind of chemical reactions and particles, it get the size get increased. So the characteristics change. That means absorption capacity initially emits when this fuel emits or biomass burning happens. That is the particles that time and particles after 7 days. That has totally different. So here this is kind of, see the effect. This coating mostly materials like sulfate, nitrate. So there are several factors which deposit this one, and the absorption properties of black carbon get changed. And this is very important to the model, because model only estimate when the pollution emits from particular sector, but they never count when it is kind of remote places or the Northern Indian Oceans, or if pollution travel from one place to others. So it is not only a problem to the emission inventories, it also problems to the models when they call the radiative effect. Mostly IPCC report, they talk about radiative forcing by different black carbon, sulfate or something. So if you see the direct radiative forcing, when this is emitted, there is like local sectors, the radiative forcing is 0.4 watts per meter square. But if it is after 7 days, it is increasing to 1 watt per meter square. There is a huge difference, 2 to 3 factors difference is there. So this observations helps to models to clearly estimate the radiative forcing. And to study this one, how this pollutions travel from Pakistan or India to Bangladesh, and how it changed during this long-range transport over the Northern Indian Ocean, we conduct several campaigns. Like research, we do campaign with the different objectives. But this kind of object, like a SAPOEX, South Asian Pollution Experiments, we conducted to understand the properties of the black carbon. So if you see here, distance from Lahore, Pakistan to the Bangladesh is kind of like 2,000 to 3,000 kilometers. And from Bangladesh to the called Hanimadu, we can say, this is 3 to 4,000 3 to 4,000 kilometers. So total distance travels like 6,000 kilometers. So when we see the particles, which generally, for example, emits from Lahore or Delhi, it's transported to the Bangladesh. So size get increased. So if you see this MAC is nothing but mass absorption cross section. That gives the capacity how much the particle absorbs. So the MAC, it starts when it is first slide I showed, when it is emit from sources, it is kind of around 1 or 1.2. But when it comes to the Bangladesh, it changes to 4.2. And real interest, see the particles again, when it is traveled from Bangladesh to Maldives, it gets increased again. So the capacity of MAC capacity, absorption capacity get increased. So that capacity increase like up to 80%. And how we came to this conclusion, because we have observatory here in Bangladesh. We have a similar kind of setup in Bangladesh, Bolak Island. That's called Bola Climate Observatory. So we have similar setup which has at a Hanimodu. So with these results, we calculated, we did some observations there. And again, during this time, winter time, we have observations for Hanimodu, and recently we started observations for Gan. So again, we are trying to establish one more observatory in the Gan, so which gives more facilities to track this pollution fumes. So during this experiment, we found that particles, mostly black carbon particles, when travels to the long distance, it get coated and change its capacity. But when you talked about the brown carbon, which is component of organic carbon, it has capacity, little capacity to absorb sunlight. It gets, again, cause to warming. So that effect here, first you can see, I will talk about this first figure. These are these observations from Bangladesh, Hanimodu, and Gan. If you see the first one, obviously this black carbon and brown carbon contributions, you can see there's a less contribution here in the black carbon, black area. Where it's getting increased, the BC and EC, the proportion gets changed. Over the Gan, it's changed. So the MAC is getting changed, capacity is getting changed. Means the proportion of black carbon is get increased. But at the same time, if you see here, brown carbon, the proportion is happening reverse way. The brown carbon, when it is travel, it gets bleached with the photochemical reactions. It gets bleached, so it removes the coating, and that we can see here, effect here. So this is increasing time, here is a decreasing. So we can conclude like both this brown carbon and black carbon has different properties. So that need to address in the climate models. So get the accurate results. Also, if you see NaCl ratios over these three sites, our finding is like NaCl ratio, ClNA ratios at Bangladesh is very high due to this kind of pollution activity, industrial activities that Bangladesh is too high, which produce the chlorine in the atmosphere. But that chlorine is, when it's traveled to the northern Indian Ocean, it gets depletions. Means we can say here more problems of the chlorine here over the Bangladesh. So this is the, again, key messages from these studies. So which is published in, actually, this article published 2 days before only in SCP. So I included this one here. Yeah, just now I talked about this opposite trend of brown carbon. If you see again here, Delhi, we have observations over Delhi. Here, Bangladesh, Bangladesh, and here, Northern Indian Ocean. If you see the black part, is this kind of total carbon. If you see here, it's a percentage 30 and 32, 39. It's getting increased because there are a lot of industries activities are happening. So obviously there is addition of pollutions in the, and we get higher carbon content. But if it is traveled to the Maldives, the content get decreased. But here you can see the blue one, green, which is kind of anthropogenic component rather than black carbon. So that get increased here over this Hanimodu. And to further study, we use this aging model actually. You can see here aging model. So we measure the MAC of brown carbon. Background you can see this is AOD, that means gives the idea of pollution level. It start, if you see center is the Bangladesh, and if you go minus, that is Delhi part. Means that's you see this way, reverse way. And this is over to the Maldives. So this is kind of total 6,000 kilometer distance. So we calculated like how much that bleaching is happening. So we calculated with these models like it's happening 0.2 per day. So it's a plus minus 0.0. There is a kind of always uncertainties there. So even that, these small things we calculated with these results. I will not discuss more things about the sources and other things now. So here key message is that what this is like the we calculated here. One of the finding is the rate of bleaching. This is the first study in the world which is published in Science Advanced. We came with the clear numbers. Yeah, And then comes to the source part. Initially, when I talked like why we need to make it separate sources like a biomass burning or fossil fuel. So here, the first study in South Asia, which is conducted by the professor, which is led by the Professor Gustafsson, in 2004. That time we realized this is biomass burning is the main problems in South Asia. So as a scientist, we reported this in 2004, but this is only for like 1 or 2 months observation. So people not it's convinced with this study. They ask like this is only for short period and can't represent entire period. So again, I came with the full year study in 2015, and we found that this is the only one study so far in the world, which based on the radiocarbon data analysis, which clearly shows that there is a 50% contribution from biomass burning and 50% from fossil fuel. So this is so far only one study in the world. And here again, one interesting thing happens. If you see comparison of, here you can say Sinhagad. Actually, Sinhagad, that is the receptor sites in over the India, where I did some of the work of PhD, that station. So we found here during monsoon period, as expected, the biomass contribution is getting down because there is not, because of lot of rains and not polluted fumes. So that is happened. But here Maldives, it happens different way. We get the more biomass burning. So there I put like this point I took for me as a postdoc study, and I came with that results, like a reason why we are getting high signals of biomass during that period. So here you can see here, mostly India and this Maldives. The red color you can see that's mostly air comes during the dry season, winter time, and this is the blue one when the winds come, it's rainy season. Same here we can see. And these are the transition months where the wind is changing their directions. So this takeaway message from this is like for the first time we clearly shows that the percentage contribution from biomass burning and fossil fuel. Now I shift, like a second part, I move to like during southwest monsoon. So southwestern monsoon, mostly winds comes from this direction, from the Indian oceans. This is like from satellite observations. Again, here you can see the local met data. So the winds dominate that track. And again, this is model studies where we can see the red spots, means that is kind of more frequent wind is coming from that part. And these are the sectors actually. During southwest monsoon, we can receive some winds from initially from Arabia, then Africa, then some of the winds mostly comes from Australia. So these are the sectors we get wind during this southwest monsoon. And if you see these concentrations, again, I'm following the same like what I discussed in the northeast monsoon. So I will follow like size distribution. During this period, we can see these observations came in the 14 to 18, and then we after 10 years, we again came with other observations with the different instruments. We still found that there is a number of particle numbers are increased. Size distribution a little bit increase. We can see here the difference, like clearly difference in the size mode as well as number. During northeast monsoon, we can see the 1600 particles within 1 centimeter cube, which drops during southwest monsoon, comes like a quarter one, so 1/4 it's got. Yeah, and now the interesting part of this study is like to highlight this one. This also published in PNS, this is one of the reported journal, where we have compared our data sets. Like earlier I point out, like in southwest monsoon, we get more biomass signals. So if you see that this is kind of, first of all, you can understand this is the color, different years, and this is when the winds come from Indian Oceans, Arabian Sea, or savanna. Savanna fire means the fires which happens in South Africa. Mostly we call that event, they call savanna fires. So these are the 3 points during this entire 5 studies. We found the signals biomass contribution is more than 50%. It's more than what we expect during this monsoon season. So when we see these end members, mostly it comes from, this is the C3 plants. C3 plants means, for easy understanding, means C3 plants, if you compare C3 and C4, 90% plants mostly comes C3 category, and C4 is 5%. C3 plants comes in the wet season where the soil temperatures varies 4 to 10 degrees Celsius, while C4 plants, the needs comes in the temperatures of the earth is, soil is like 15 to 20 degrees Celsius. So this is warm soil. So we can separate out C3 plants examples like all kind of trees and grasses. But here C4 plants like sugar canes, this has like different photosynthesis reactions. So C4 plants only during this southwest monsoon, we can see that signal source South Africa. So we can conclude here like whatever this pollution emits fumes we found during this southwest monsoon mostly comes from, we see the back trajectories, like first model I said that from the winds mostly comes during that period is from South Africa. So when we we have seen this trajectory analysis, so during this time the winds mostly comes from Africa. So this is also give the idea with the wind direction as well as with this 2D model, which is called as based on the carbon 14 and the carbon 13. And this is the 3 end members. So with this model's results, we also do the Monte Carlo simulations. With that, we found like, obviously this fossil fuel contribution is high during southwest monsoon, like around 65%. But we found like 3 samples which is affected by the savanna fires. And over the Maldives, we have C4 contributions like 6%, and the C3 biomass like affected by 94%. Yeah, and now coming to the brown carbon part. If you see here again comparison with Maldives and India, we can see monsoon time brown carbon concentration is less. It's order of actually less than winter period. And the contributions like based on this carbon fraction, carbon 14, that is a little bit different sources, like a 20% from fossil fuel. And also these particles like brown carbons are important because it plays major role to the cloud formation. Now the first part is finished. Now I'll move to the second part. Is there any difference like when the particles which are in the dry conditions and when the particles in the wet? That we can do like a normal day, we do the filter observations, air can filters, but the wet particle we collect the rain. So that will give idea like the comparison of dry aerosols and wet aerosols. So here this is again the arrow shows the 2 different seasons. The concentrations here, see like again here like a lot of difference during this monsoon season we get less concentrations, winter we can get high concentrations. But the thing is like when we see the optical properties here, these optical properties here like MAC, this is more during this southwest monsoon. That is kind of again one highlighted like we picked from the studies. We say like the MAC is not depends on only this, other properties also depend on the ratio of how much black carbon and organic carbon present in the composition. And so this study helps, like if you compare this dry and wet, we can calculate this scavenging ratios. Scavenging ratio means, or washout ratios gives the idea how often, means like how much that pollutant wash out particular period. So here we can see this, if you have like a composition in air and composition in rain, we can calculate the washout ratios. So here you can see the black carbon, it has a less washout ratio. That means it is not easily removed by the rain. So it will sustain more time in the air. So that is also one of the indications the black carbon, once in the atmosphere, that will stay a longer period. So that this will help with this washout ratios. And also if you calculate the fluxes, we can see the fluxes. And importantly, these calculations are somehow perfectly matched with the models. So this is kind of encouraging things here. Yeah, now I will talk a little bit about the gases especially carbon monoxide. This is very important because indirectly it is also affecting as for greenhouse gases. So we have found, like, based on this observations, we found like carbon monoxide sources, mostly primary sources for South Asia. It is interestingly, like in the global scale, there is a decreasing trend in carbon sources, primary sources. But here in South Asia, we are getting increasing trend. So there is also concern here. We found during the studies. Here you can see this chemical productions contributions globally is high compared to this South Asia. Yeah, now I think most of you can be interested this one, how much pollution is emitted by Maldives, because there is kind of, we are talking about northeast monsoon, south asian monsoon, but there are some sources over the northern India ocean, like Malay city is one of the, where we can get more carbon particles. So we came with this study, actually with the help of Ibrahim and other colleagues. We conducted one full year campaign in Malay. We do the observations for the Ragu building and came with these conclusions. So this it happens during 2013 when we collect year-round observations during Malay. This is like the last 15 days from where this wind is came. So during this observation period, each trajectory you can see during this southwest monsoon, and this is during northeast monsoon. So, and here I put it when we talk about pollution, generally people talk about PM 2.5. If the PM 2.5 particles, they call as air quality index. So this is one of the important parameter based on PM 2.5 level. If you see the WHO limit is they established in 2005. I am using only 2005 because later on, like a recent year, they changed 2021. Their guidelines changed, but they have, instead of 10, the guideline came to the 5. So that is kind of more concern for human health. So if you see the compositions like PM 2.5 concentration over Malay, during 2013 itself 19, which is almost like double than WHO limit. And it is not happening only Malay, but it's also happening in Hanimadu. So whatever the air is breathing in Maldives or the Indian Ocean, that is not safe. With these conclusions, we came here. And if you see this year-round observations, we found like almost 75% times the limit, critical limit is above the WHO limit. And it's similarly 70% at Hanimadu. Then coming to the more results, like you see the PM 2.0 concentrations, the black one represent Malay, and the whole shape represent the Hanimadu. This is the WHO limit. So when the winds are like PM 2.0 concentrations more than PM 2.5, which is not good for human health. So we have to concern about this. And this is the concentrations again. This is rainfall, PM 2.5. Again, like comparison between the rainfall, and during this June period, Malay experienced like a less PM 2.5, while it also depends on the rainfall. So, and for Hanimadu, we get August month less PM 2.5. And here picture, if you see this one, black part, it's from local contribution from Malay. So how we can calculate? The simple thing is like, we expect like whatever the winds comes to the Maldives or the Maldives, it's the same for Hanimadu and Malay. So if you have same day observation as Hanimadu, we have same observation at Malay. So if you minus Malay from Hanimadu, we'll get the local contribution. And here you can see during actually monsoon, we have like more contribution pollution during from Malay. And this is again, we can say that depends on the wind directions. Other observations we found Tilupusha Island is affecting the Malay air quality. And yeah, this is kind of a takeaway message. And the last part of my presentations, like COVID-19, it's give us like a good opportunity to study the environment. If we make a completely zero emissions of the sources or activities, what will happen in the climate or how the long-term or short-term effects can be possible. You see the picture here, like famous picture actually. It's Delhi actually is kind of when pollution event happens and during the COVID period. So you can see the clarity, how much pollution is emitted. Yeah, first we started with this during COVID period. We did observations. Like actually, our observations continuously since like 2004. So it never stopped. So before that, during COVID period, we see the satellite pictures, top of the atmosphere, 3 kilometers. With the satellite measures, we did with Moody's and Cirrus satellite. So, and this we consider this is 2007 to 19 is the period we compare with 2020. So we compare, there is a decrease in aerosol at the top of the atmosphere. Similarly, a decrease in total atmospheric fluxes actually here, 2.5%. The thing is, like, if you see overall Earth, there is a blanket of aerosols or gases around this Earth. So if you consider this is the mask, and if you remove that mask, so what will happen? The sunlight comes directly to the Earth. So what happened during COVID period, the masking which removed for temporary period, though get more sunlight in the, or the, like especially if you talk about South Asia or the Maldives, we get more solar sunlight. So there is a kind of brightening. So if demasking, then comes surface brightening, and when the sun rays reach to the Earth, there is again problem, like it gets warmer. So temperature get increased. So if you see this fluxes, we calculated over this Honeymoon, like see during this 2020, there is an increasing 7%. So whatever the sunrise reach over Honeymoon or the Indian Oceans, so there is an increase in 7% during this COVID period. And here is kind of sea surface temperature observed by satellites. There is an increase in sea surface temperature like 0.5 to 1 degrees Celsius. So if you remove completely all the sources or emissions, that's not good again. So we have to think that way also. And if you see total overall, so far I talked about AOD, particle number, black carbon, and incoming solar radiation. There is a kind of AOD decrease like 40%, black carbon 60%, and incoming solar radiation 7%. And when we compare this to the overall, this so far I talked about IGP, South Asia, and Honeymoon. You see IGP, there is an increasing like a surface brightening, so around 34%, but over MCOH is 50%. It's like we can say over the Maldives, and there is a demasking effect over Maldives is 9%. So this is overall picture of Carbonaceous or the Indian Oceans. Now our scientists, one of the scientists can also help, like people always talk about sea level rise, and estimated like in 2021 it's 2021 it's, the sea level rise may be 75 to 200 centimeter. But if you reduce this short life climate pollutant like black carbon, we can still decrease like a 25 to 20% warming, and that will help to the rising of sea level. Yeah, I think I finished my presentation on time, and I'm happy to answer your questions.
Thank you. Yeah, maybe we can have very quick 2 or 3 questions.
Thank you, moderator, and thank you, Professor Krishnakant.
Okay.
Yes, right. It's a very fascinating presentation. I am assistant professor here teaching politics of environment and policy of environment. And this is a whole lot of new information for me, very impressive. Thank you for that. My question here, of course, you're talking about black carbon. What can the Maldivians do to reduce, by changing our lifestyles, what can we do to reduce or stop the creation of or production of black carbon above the Maldives.
Okay.
Second question is, we hear in Dubai there is artificial rain they are creating now. And so I wonder whether scientists have discovered any new technologies or chemicals that can help clean air pollution. Like now we have a solution for cleaning up the polluted rivers. So similar manner, do we have anything discovered that can clean air pollution?
Yeah, I will first talk about your first question. I'll try to answer first questions and then come to the second question. First questions, like as a Maldivian, what we can do to reduce the emissions. Especially if you see Maldives, Maldives has the luxury to use the sunlight, which has a solar energy. So whatever the energy generated in the Maldives, like with the diesel actually, all this happens producing energy with the diesel engine. So somehow that at least the daytime that can be shifted to the, we can say, to the solar energy. So that can little bit help. Again, if you see particularly Malay region, there are a lot of vehicles are there. So somehow that if you encourage people to use the kind of local transport, like government transport or local transport for their regular activities. And also I found, like I'm working in Maldives like last 10 years or more than that. So I found like a lot of trees are cutting over this island for the development purpose. So these trees are actually very good absorber of CO2. If you remove the trees, it will like, we can't capture the CO2. So that help increase the temperature. So indirectly that will also affect. And also there is like some mangrove trees are there. Actually mangroves are very efficient to capturing the CO2. If you see 1 square kilometer area of mangroves can help, which is the cars emits like 90,000 cars emits pollution full year. So that also very helpful. As a Maldivian, I can say these things can be possible to act as. And coming to the second point, like artificial rain you are talking about, but I don't know how reality that is kind of implemented. It's all depends on the, again, like what kind of clouds are there. The things start from there. So for air pollution also, we are facing different pollution during different monsoons. Mostly when the winds comes from the India, it's like from South Asia, we get polluted air. But even though if you have like, we are getting clean air through the southwest monsoon, but still the clouds are affecting to the biomass burning from the Africa. So I don't think there is kind of so far any techniques comes we can clean the pollution in the air, because it's kind of broad things. In room, actually in our home, we can do use the clean filters or kind of things that remove the dust. That will really helpful for particularly in Malay, like there is no, the area is more congested and people are not getting kind of enough clean air. So that possible to like have more ventilations and air filters at the home. So that will really helpful, not only regular, mostly that is more important for elder people as well as small babies. Anything? If you want to discuss more, actually, I'm conducting one more tomorrow 3-hour section, so I will go more details in the studies and we can discuss more things.
Yeah, thank you very much, the audience, because we also ran out of time. I would now kindly invite Deputy Vice Chancellor to give away the token of appreciation to Professor Krishnakant.
Thank you. It will be a pleasure.
Thank you very much. And I think this, from Professor's talk, we have learned that the Maldives is also doing a lot in the science front. We always hear we are only going to these international meetings and doing more talk. But now we learn that we are doing a lot of science, contributing a lot to the scientific research in the Maldives. And thank you. So I think we have finished all the